Let's
Okay,
go.
well, let's get started. So, long story short, so Vincent and I have known each other for I almost said decades, but I mean
Yep.
it's longer than 10 years now. And 10 years ago, we used to do a monthly call where we would share ideas around cybersecurity, and then with a diversity of knowledge sets, we would discuss how do we be more secure. So the spirit today is the same. It's like, how do we be more secure? How do we be more compliant? And the regulators have gotten into this world where they're challenging us to ensure that we're taking certain policies, procedures, and techniques or tools that we have in place to make sure that we are secure. So that's the whole spirit of today. So the spirit of today will be very much about the cloud. Okay, so all of us end up using Dropbox or Box.com or Office 365. These are SaaS applications that are being run on computers somewhere else. Most of us also have an environment at either Azure, usually Azure, probably with the group of people on the call today, but also many folks, we have groups of computers at AWS or Amazon. So most of us are managing computers that are not physically near us. They're somewhere in this nebulous cloud, right? So today is all about, and it'll be somewhat technical. I mean, depending upon your background, all about how we, as users of the cloud, secure that. How we make sure that nobody that shouldn't view our private information, whether that be your personal tax return you have stored in Office 365, or that be some little FinTech application you've spun up and built. Today is about making those things more secure. So with that, I'll turn to the next slide. I have a couple guys with me today, Lesko and Patrick Cara, that are just exceptionally technically deep. Okay. So they are going to, and Les will lead today's discussion because he's very much focused in the cloud. And then Patrick will lead next month's discussion around kind of the history of hacking and active threat intelligence and what we should do about that. So that's coming in May. So a month from today, if you want to learn about who are the largest hackers on the internet, what are they doing, and how are they impacting me, come to that session in May. But today is all about the cloud, and all of us have the cloud. So Les will lead that discussion. Vincent, a major partner of Security Basecamp, Buckler is with us today as well. We do all our risk assessments today in Buckler. We do a lot of management of our cybersecurity policies, programs. What should we do to ensure we're secure as it relates to what FINRA and the SEC guide us to do? That's Vincent. Okay, so we use a lot of his software to do our work and to guide our efforts in a regulatory compliant manner. I'm almost done talking. Today's agenda is all about this challenge of the computers we all use in the cloud: Office 365, AWS, Azure. What risks do we end up encountering, and how can we mitigate those risks, and how can we make sure that our clouds, our computers, our tax returns stored elsewhere are kept safe? So, and then we'll get into any comments, questions that you want to deal with. So that's my intro. Les?
I think this is still yours.
Yeah. So if you think about where we're going today, what we want to talk about, it's primarily going to be about, you can't just buy Office 365. You can't just open up your Azure environment, your AWS environment, and say, oh, good, we're good to go. I mean, the reality is And there are nuances. It differs by platform. You need to make certain changes to your environment to address the cloud security risks that exist. Don't just go and here's an analogy. Don't just go to Best Buy and buy a new wireless access point or a quote unquote firewall for home and plug it in. I mean, it probably has a default password that you can Google what's the default password for this Meraki device that I just plugged in at home. You don't want to be using defaults. Okay, so we're going to talk. Les will talk a fair amount today about making sure that you just don't fire up your cloud, bring up computers, spin up a server. I now have a web server. Just don't do that without making the changes required to make you more secure. So that's one thing. Les will talk a lot about best practices, and some of this will get a tad technical. I mean, depending upon your background, as it relates to how you ensure that nobody can access your computers in the cloud that shouldn't, and nobody can access information. So I'm 7 minutes in. I want to stop talking in a big way. Les, let's turn it over to you.
All right. Hi, good afternoon. And for those in the West Coast like myself, good morning. My name is Leslie Coe. I've been in the IT field for a long time. One of my first jobs was actually running cables. And did you know that you can actually run a network on barbed wire? I actually helped a farmer connect his barn PC using barbed wire on ArcNet. This was before Ethernet was de facto standard and before Wi-Fi. Anyway, I've been in IT since mainframe, so I mean they're still huge right now, but after the punch cards, of course, because I'm not that old. Um, did servers and then networks for a few years, and then finally firewall and security appliances. The last few years, it's all about cloud and AWS, Azure, Google Cloud Platform. So I've been focused on that quite a bit. So. What you see here is a model of a fortress, a medieval fortress. I'm talking about like fortress, not the bougie castles like Versailles or Buckingham Palace or something. So if you look all over the world, they all have one thing in common. So the castles in Spain, the Agra Fort in India, um, they all have several things in common. They all have your thick outside wall, right? And then they have an internal wall. And then inside that, you have your main castle or palace, I guess. And each section of it has their own doors. The front has a portcullis and all that. And the innermost chamber holds your crown jewels, right? Over here on the side, you will see your courtyard with all of the merchants that does business in this little kingdom here, and you also have these little maze to slow down uh, people who are not familiar. The merchants, they go in and out every day, so they just walk right through. But those unfamiliar will have a hard time going through this little maze. All around the castle are these battlements or towers where you have your guards on the lookout, and um, I guess they're just looking for invaders who are coming. So this has stood the test of time for thousands of years, right? So it makes sense to use this model for networks, right? So your external wall is your firewall, your external firewall. You have an internal firewall that protects you should the invaders make it past your external wall. You have your merchants here, which would be your hosted services like your web servers, your application servers. Your databases you would keep in the main tower, because that's your databases, your customer data, accounting data, important stuff goes in the innermost chamber. You have your security appliances here, like your WAF or web application firewall. I'll talk more on that later. But basically, it slows down attackers. So, and in the front gate, you have your guards or your identity access manager. Um, the old term is like network admission control. And of course, firewall rules that says who can get in and out of that front gate.
Right. And I just
And
want to make one mention. So when Les talks about IAM and that entry gate, I have seen even among folks that don't know a lot about cybersecurity, a fair amount of discussion this year or in the last 6 months around something called conditional access policies. They are very related to what he's talking about there, making sure nobody gets through that front gate that shouldn't.
right. Um, and then over here in the towers, you will see your logging server, your network management server, or network monitoring server. They're always on the lookout of if there's any suspicious traffic going on, right? So,
And
so
just briefly, another mention. So
yeah,
SIEM, Security Incident Event Management, is also becoming more popular and required by regulators like the New York TFS and the SEC guiding us to ensure what are you doing around logging? And is it more than just storing logs somewhere? Is it are you making any intelligence of trying to correlate events, meaning, gosh, it looks like Patrick, who's an ethical hacker, right? It looks like he or somebody that might be an unethical hacker has actually gotten in, and here's how we know
yeah. So this is a typical security group in AWS. So remember that most companies, Microsoft, Amazon, Google, when they build a system or give you access to a system, it is designed for usability. And this has been true, ever since like even in the early 90s. Um, Even the routers that Paul had mentioned earlier that you can buy at Best Buy and turn it on, and the default is to make it usable. Otherwise, they'll be fielding thousands of calls, a day. So by default, when you just click, when you start an instance, you just click next, next, next. This is what you get. And over here, it's basically allowing this service coming in from anywhere and allowing it to respond going to anywhere. So by default, it's for usability, not for security. It's very easy to change it though, and Amazon in this case expects you to change it. So when you start an instance, there's a drop down here that says anywhere. You click that and you say my IP, and that's it. Maybe you could put a description over here just for readability down the road, but that's pretty much it. You've just said that to access this. And for those who are not familiar with SSH, this is how you access that machine, that Linux or Unix type machine. Um, like that's how you access a shell on that machine and gives you like God mode on that machine, pretty much. Um, so just by doing that, you've said only your workstation can access the machine that you just spun up. Later on, you could then add the services that you want to run on that. In this particular case, this is a web server, so it would run port 443 on it. Um, a typical, or at least the way I do it, is I set this up to only allow myself access to this machine. I then patch it because remember, when you're spinning up an image in the cloud, these images are built several months ago. So it's not hasn't been patched in months. So what I do is I spin it up, I log in because I'm the only one who can log in. I patch it, I turn on the firewall on that machine. I set up the applications that the application developers are building. In this case, it's a web uh, application. I turn that on, I secure it, and then I open it just to the developers for them to say, yes, it's good. And then after that, I turn it over to them and I open it up to the public. Most people ignore this bottom part, which is the outbound rules. For production, I wouldn't do that. For production, I would say if it's 443, which is HTTPS traffic or web traffic or secure web traffic, I guess, sure, you can go out anywhere. But for things like SSH, which is very dangerous, I only allow that to myself or the small list of admins that should have access to that. So this is a typical or a traditional network topology. It's been around forever. You have your internet on this side. You got your external firewall, your services, kind of like the castle or the fortress illustration earlier. You have an internal firewall with a database. The database can only be accessed by these hosts here. And of course, you've got your main database inside the castle keep, right? And usually you make a copy here, like a one-way sync of sorts. So,
Right. And just a quick pause, keep this picture here. So many of our clients, especially a financial advisory practice, when we start talking about things like DMZs, right? Think if you have any interest in knowledge of history, the DMZ, this safe zone or this semi safe zone or semi dangerous zone, depending how you look at it, right? You're going to use this initial zone as a place to make everything inside or your internal network more safe. The reality is this: most RIAs or smaller financial services companies almost have no concept of thinking about this. And as Les moves from describing this concept to the cloud, it's just really important to make sure you're doing the basics.
right. And thank you for bringing that up. Most, I guess, new to IT people typically say that DMZ is an outdated concept because everything's about the cloud now, right? Well, it actually isn't, and that's why I brought this up. What I'm showing here is a traditional network topology, uh, but just because it's traditional, that does not mean the cloud doesn't or cannot uh, do it, right?
Yep.
So this is a model of AWS again. You have your outside network here, which is your outside firewall. And that was what I was showing you earlier in this slide. This would be the definition for your outside firewall, right? This guy here. And then you have your public subnet, which is typically your DMZ. Of course, they don't call it that anymore, but it's there. Um, and what a lot of new folks are not doing is they're not building a private subnet, which should be where you're keeping your important information, like your databases, your if you have a customer accounts database, that's where you would keep it as well. User accounts databases, everything that is important to you as a business. So. And to do that, you would go to your virtual private cloud and you would uncheck this enable auto assign IP address. And just by doing that, you have just secured your that bottom subnet and turned that into a private subnet. Now, when you spin up new machines in that private subnet, this auto assign public IP address is gone. It's basically disabled. And then down below here where it says SSH traffic to anywhere, the first slide I shown where you could say just my IP. well, it doesn't really matter because nobody can get to it anymore, but I would still set that to your VPN or your Bastion host machine. So this model, right? This is the private subnet. Just by taking out auto assign IP, that's where you would build your database server, and nothing can access that anymore from the outside because um, this database server will now have a private IP address, and RFC 1918 says that those addresses are not routable.
Yep.
So, but of course, you still need that machine to be able to go out to the internet to get patches. Like I mentioned earlier, you should patch it before you put it in production. So you would then put a NAT gateway. And this is an Amazon service. It's not something that you spin up yourself. You just turn it on, and then you set up the routes down here. So, but I still need to access that, right? So I can manage it. To do that, you would have a VPN or a Bastion host where you could log in, make sure that it's secure, make sure that it's logged to make sure that every person who logs in there, who's doing that. They have the keys, so on and so forth. And again, logged. Or Amazon has workspaces, which is a Citrix like it's virtual desktop basically. Um, and you could access it in that manner. This one also supports multi-factor authentication, and it can sit turned off, so you're not getting charged for it. You're just getting charged for storage. And then when you log in, it automatically turns itself on and allows you to log in. So that's
Right.
another way
So
of doing it.
let's just all think about this conceptually, right? So we've just named, and Les has shown us how to make sure that only computers that we know can access our crown jewels. Two, I want to create a safe zone, kind of an initial landing spot where people are going to touch the internet before they actually get to my crown jewels, my database server, the application I build, my tax returns, my highly sensitive financial plans. He's created a way to make that safer to access those things, and pointed out that we should also, he mentioned logging. Well, who's been accessing my crown jewels? FINRA, the New York DFS, the SEC all say log that activity so that, God forbid, somebody that was a bad hacker, Patrick's an ethical hacker. If a bad actor accesses our data, that we would know who that was.
Right. That's very important. Most bad actors, when they compromise a system, they linger there for sometimes almost a year before they even do anything. So I think Target was one of them. They were there for like 6, 7
Six
months.
plus months.
Yes,
Yep.
absolutely. So nobody knew the better. So okay. This is so these pictures here, the web front and the database server, these are the actual servers. Inside of them, you could run a firewall. In our image earlier of the castle, right? You have your the merchant huts there, and of course the main castle. Just because they're inside the thick wall, fortress wall, and the thick inside wall, that doesn't mean they don't have front doors, right? And guards, of course. This would be the equivalent of that front door, right? You would still want to keep that safe, and in case the invaders pass through the first wall, the second wall, and now this, right? So the key here is layering. Um, so this would be that, I suppose, final wall, right? By default, this is a Linux or a Unix type host. By default, this is set to public. what I recommend is to set it to drop. Public basically notifies the attacker that they have been blocked. So if attacker hits this box and it was set to public, it would say, sorry, you can't get in, you're blocked, which would challenge them further, right? Ooh, I'm blocked. Okay, now what can I do to get in there, right? Setting it to drop basically does not set or does not send a a prohibited an ICMP host prohibited message. It just simply drops it. So from the attacker's point of view, oh, maybe there's nothing there, nothing's responding. So I would also set services that run on this machine, right? This is a web server, so I'm only allowing these guys, these ports, because if I allowed all ports in, um, it there could be insecurity on those ports, and the attacker can get in that way. It's
Yeah.
like
And
opening all the
describe what a
windows, right?
port is. I mean, how many ports are there? I mean, do we all have ports?
Oh
So
yeah,
what?
there's 65,000 ports, 65535 ports that are open. Each service runs on a port. So Secure Shell, which is this SSH, runs on port 22. Web typically runs on 443 and 80. 80
Yeah.
is your unsecure one, HTTP, and 443 is your secure port HTTPS. If this was a Windows box, it's what 3389 is
Yeah.
their remote desktop.
Yeah. So
So,
everybody on this
yeah,
call, you have entry points or ports
right.
into your even your laptop, right? So
Yes.
and they have specific um meanings or specific things services are allowed, like Les said. And it's really important to make sure, and that's one thing we do in vulnerability scanning, is making sure you don't have the wrong ports open.
Yeah. Well, unused ports or ports that you may not even be aware of.
Better said, yeah.
Yeah, yeah. So, and again, secure shell's kind of dangerous. So, what I would actually do is use a rich rule which defines a source address. So this would be my Bastion host or my VPN server, um, or my Amazon Workspaces IP, and only allow port 22 or 3389 if it's Windows access to it. So a lot of companies now do serverless. This is Amazon's Lambda. Um, and again, usability over security, right? By default, Amazon Lambda is designed to be accessible publicly. They have a public IP address that you could reach. Same thing with S3, which is their simple storage. So, but you can also bring this inside of your castle wall because by default it would be on the shores of that little castle analogy. They're not even through the drawbridge, but you could bring that in, and that is by assigning it to a virtual private cloud, a VPC, and attaching a security group there, which is a firewall, an external firewall, right? So same thing with S3, which is their simple storage. It's like a giant hard drive in the Amazon cloud. It's also designed to be accessible publicly. Um, you can attach access points to it and make it private. That way, the Lambda and the S3 can talk to each other. A lot of Amazon services behave in a similar way. And there's thousands of them, Lightsail, RDS, there's tons of them. But they pretty much behave in a similar way. So you just have to make sure that you secure it before it's, given for everybody's access. And to do that, you would go to the VPC dashboard and assign an endpoint to it. So, identity access management. This is the guards in the front gate, right? These are the leaders. This is a Gartner Magic Quadrant from last October. Big name would be Okta, and Microsoft, of course, Ping Identity. Um, So when you hear them, that's when you hear about these companies, this would be identity access. So that would be that guy over there. So what I have on the left-hand side is AWS, and on the right side is Microsoft's version called Entra. So for AWS, again, usability versus security. By default, anybody in the world can log in to AWS, um, to your AWS. So they could eventually guess your password if you don't have MFA or multi-factor. But you could stop that. If you go to your IAM, you could go down to policies and you can cut and paste this. We're going to be posting this slide, well, a PDF copy of the slide. Uh, so you could just type this up. And what is here is IP addresses that you own. So this could be your office IP address or a VPN IP address, something that does not change, right? Or if you're using Amazon Workspaces, it would be that, right? This is a reverse logic code. So it says deny everybody unless you are one of these IP address. So if you're not those, you cannot even log in here. Remember, this controls by if you're able to log in here, you can control everything. You're controlling the firewalls, you could open up everything. So this would be like the keys to the kingdom. So you better make sure that only those authorized here can access that.
Yep. And I will say here, I want to interject. So Les and I, via risk assessments we've done, even on RIAs with 2 to 3 people, right? They never deal with this. They literally don't deal with this. So Les has helped those sorts of clients lock down that entry point into their cloud environment. In almost every RIA and clearly every financial institution is dealing with this issue. And if they're not dealing with an MSSP, I guarantee you it is exceptionally likely that almost anybody could log in.
Right. This is Microsoft's version of it called Entra. And there's the conditional access um, menu option. It's under identity protection. You start by creating a named location. So earlier in the Amazon side, it's all text. Of course, Microsoft's all GUI. This is where you would set those IP addresses, or you could say by regions, right? So US and Canada is allowed. Um, so you would take that name, you would then go up here to policies, and in your policies, you would say network and select that named location that you've specified earlier. Again, this is a reverse logic. It is block all access except that named access. So, and that is pretty much best practice. You block everything and you specifically allow just the ones that you want. So,
Right? It's kind of the
other things
zero
that you can,
trust-ish kind of
right.
concept.
Yeah. Other things you can do here is you could specify what devices is allowed to do certain things. So let's say for management, I do all my management in Linux only. Then I would only check that. Um, and then over here, I want everybody to relog on every 8 hours, just in case somebody's laptop got stolen in the coffee shop or somebody left their machine on and unlocked in the middle of the office. I want that to be auto log out and or logged off, Microsoft term, um, every 8 hours, right? Persistent browser session. Sometimes people just close their browser without logging off, right? If you put a check mark on this, when they turn on that browser again, they would have to log in or log on. So, and of course, on this side is what do you want to do after all of these rules have been done? You either grant access or block access. Well, you can say grant access only if they have multi-factor authentication, right? It could be Microsoft's multi-factor, or it could be a third party like the bottom one here. This is Cisco's Duo MFA. Um, for really, really critical data, you could require more than one, and that's by clicking this radio button here. You say, I require all of them to be true, right? Or three of them to be true. Um, Make sure that they're using the correct app. They have a strong authentication and multi-factor, right? So security appliances and um, so that would be the maze here, right? For people who are used to coming in and out of here, they will just walk right through the maze. But those who are trying to invade, they don't know the lay of the land, they would obviously get stuck and they would look very suspicious. So, web application firewall is exactly that. Um, you have a web application internally in your marketplace there, and they behave a certain way, right? Like they sell wheat, they sell whatever, um, and they are located, somewhere in your courtyard. And they pretty much behave the same way. You go in, you buy your wheat, and then you leave, right? So people's behavior are pretty much the same all the time. Web application firewall is very similar. You turn it on in learning mode, you do your tests. Like as a developer, you do your tests, you log in, you access these pages. You if if it's a point of sale type site, you do that, and then you log off, or maybe you just close the browser and the session terminates. So web application firewall learns the behavior, and then down the road, let's say after you've gone through the motions of teaching it, you set it to enforcement mode. So now if something is out of the ordinary, this would then block it. And there's a flavor for this. These are built-in ones from AWS and Azure. There's third-party ones like um, well, there's a few of them. So Imperva is one of the ones that I've worked with a lot in the past. So
Yeah.
yeah,
But Les's point is it's going to look for anomalies, right? So say when Patrick, in the May discussion we're going to have when he's talking about how I hack into environments, likely the activity that Patrick would be doing in Les's environment would look a lot different than a normal user. Well, a web application firewall is designed to detect that and block it, right? Or mitigate that anomalous behavior.
right. And there's also several different settings in web application firewall. Sometimes it's block outright. So if it's like super important, super secure sites, you would want it to block outright. Sometimes it's allow but log or notify. So a typical deployment of an application server kind of goes like this. You create a Docker image, and then you create an EC2 instance or basically a machine. And sometimes you load that Docker image in that EC2 instance. Or if you're in the serverless environment, it would be something like a Lambda S3 combo or maybe a Lightsail. So then for an EC2 type instance, you would then go to the EC2 or Elastic Compute Cloud.
Which is virtually basically like a server in the cloud, right?
Right.
Less an
Yeah.
EC2 instance. Yeah.
Right. So you would scroll down to the bottom of that, and then you would go to auto scaling group. And this is one of the reasons why AWS is so popular. So you put in your whatever you built up here, your EC2 instance, and then you define a minimum size. You say Monday, like Monday to Fridays, high traffic, but Saturday, Sundays pretty low. So I'll start with one machine, and then if traffic goes up, like let's say a month end, right, where you have lots of customers logging into your application, you could scale out, right? It would build more machines automatically. And then when you're no longer needed, it would automatically turn it off. So this is what makes AWS a huge hit to a lot of companies. So, and then of course you want a single point of access. You don't want your customer to log into WW1, or like server one dot security basecamp, and then your other company, other people who's logging in with server 25, right? You want them to always go to www.securitybasecamp.com. So this goes in front of your auto scaling group. That way they only have one target, right? And this determines which machine it goes to depending on load or stability. So it's cool, right? It's great. You have your auto scaling. It can keep up with your demand, and you only have a single point of access. Now, to do that, you typically have what they call infrastructure as code, right? So your developers would build something like this. This is a Docker Compose file that says, this is how I want the machine to be built. I have my configurations, like your app settings and whatnot. You have the different, I guess, services that you're running there. There's that ports thing again, port 80. Um, and the type of machine that is. This is an SQL database, Microsoft SQL. So, and of course, you have your configuration for the web server. So this is an Apache web server. There's others, of course, IIS or Nginx. So, and this is the configuration. All that is defined in that infrastructure as code, right?
Yeah.
And
I
then
mean,
that gets cut and paste times however many you want to scale. So it's cool, right? Well, what if there's a problem with that code, right? So now you've just multiplied that by the number of instances you're spinning up. So if you said, I'm willing to spin up to 25 because I absolutely do not want my customers to wait. Well, you've just now amplified your traffic 25 times. So what do you do? Well, you could run it against a infrastructure as code scanner. This TerraScan is part of Nessus. Nessus is a product. It's basically one of the best vulnerability scanners out there. There's lots of others that will do something similar, like Rapid7 and whatnot. But Nessus is pretty much like the king of the hill there when it comes to vulnerability scanner. So you put your code there. You could even point this guy to your Git repository, scan it, make sure that it's all good, and away you go. So
yeah. And for you, both you and Patrick, for, super technical individuals, infrastructure as code has become so popular, right? What are the business benefits? You illustrated a few of the security deficiencies or things we need to work out for. Why is it so popular?
well, I have to leave the benefits to Patrick because he's more access. He's more uh, approaching it from the application development side.
Yeah,
On my side, I don't like it because they circumvent the DevOps side, the operation
sure,
side, right? Because
sure.
application developers love to circumvent the
Just go.
the IT side because we're the ones who say don't do that. It's dangerous,
Yeah,
right? we we want them to come through us to make sure that it's secure before they put it in public. But
yeah,
from their point of view, we're just slowing them down.
yeah,
See, with the cloud, they can just spin up as many machines as they can, do their development super, super fast. um, without having to deal with the operation side.
Yeah,
So,
well, kind of like you want to do on the AI side, right? I mean, you would
right.
love to have massive amounts of processing power on the
Absolutely.
AI side, right,
Right.
Russ?
But
Yeah,
from the operation standpoint, the operation side of DevOps, well, we have to make sure that we control the cost, make sure that you're not spinning up 100 EC2 machines. We want to make sure that we don't get hacked because you set the firewall rules wide open. Because again,
yeah,
firewalls break apps, right? Because we could be blocking something that they need. So,
yeah.
yeah. All right, moving on. Security Information Event Manager. That would be the guys up on the battlements or the towers, right? They're keeping an eye on the inside, what's going on, and on the outside, what's going on. And of course, network monitoring. So each machine that you turn on, even your little Best Buy router, a lot of them have some sort of logging turned on, right? You have your little servers, application server, database server, web server that each have some sort of a log, right? By default, this is typically how it looks like. Each machine stores their log locally. Well, it's cool. If I want to access the firewall logs, I log into the firewall and I look at it and see if there's something wrong, right? And same is true with every single one of these boxes. Now, the problem with that is I have to log into could be 100 boxes, right? So how do you fix that? Well, you could create a central log server where all of them sends it there, which is good because now I only have a single place to look at. Well, logs typically look like this. This is coming from one device, and if you look at the time here, these 13 messages all came from this one device at exactly the same time. If I have 100 machines sending stuff there, I could have, you know, like 1,000 messages that happened all at the same time. It's very difficult for a human to keep track of that.
Yeah, kind of like logging on to Twitter or
Yeah.
something.
So it's like drinking out of a fire hose, basically. So so what do? You have your central log server. You replace that with a SIEM or Security Information Event Manager. So two things it does. Number one, it takes this type of log, make it look pretty, it still has that information down here in the bottom, that ugly looking multiple line thing. But you could what they call is enrich that, right? So I could actually compare what they've given me here, this address, and I can look up where is that coming from? Well, it came from the city of Richardson in the US, right? And it's external, and there has been threat detected coming in from that IP address.
But I thought it
So
was always going to be Russia.
not all the time. So so you could enrich it, right? And then to go one step further, you could set up a dashboard. That way, only relevant information is displayed to you. So now you're no longer drinking out of a fire hose. This SIEM summarizes the data for you. So this is a quick example of a dashboard that I created for DNS access, right? Um, there is a free service out there called Open Threat Exchange um, that keeps track of threat detected coming in from a certain set of addresses, and they assign a value to it called pulse counts. So this one here compares this address against that database and say, well, how many pulse counts are there? And then you can set up a threshold. You can say, if I hit 50 or higher pulse counts, I tag that as a threat. Um, it's it's not 100% all the time, but it's it's important to know that there is in fact threat detected in my network, right? Other things you could add, like there's been lots of requests to detect shadow IT behavior. Shadow IT is basically some of your business units trying to circumvent IT to make things easier for them, but at the
Yeah.
expense of security.
I'm going to
So
buy my own application. I'm
exactly.
going to do this. I'm going
I'm
to
gonna
download something from the internet. I'm going to do it myself.
I'm gonna store private confidential information in my Google Drive. So
Yeah,
anyway,
because you're too
so
slow. You don't get stuff done fast enough.
yeah, they want approval and everything. I'll just use my own credit card. So anyway, um, so this is a software as a service, Asana. Yeah, it's been accessed 5 times, right? I like to use Facebook at work. Um, so and other things. I want to use Viber and WhatsApp for my communication with my group, or maybe Signal. Too soon? Anyway, for
No, no. But so to that extent, and then you can put, I mean, we're not really here to talk about DLP or CASB or locking
Right.
down or preventing your employees from using things like Facebook at work. But given the intelligence, you can then make decisions about that,
Right.
right?
So you log them, you know, maybe at the next meeting you say, "Yeah, please don't do this." So anyway, so
Financial
this
planning. Yeah.
yeah, so this organizes this massive amount of information into something manageable, right? You can still click on them and see who these two counts of Facebook access, like who did that, right? You can still do that, but it's in a nice, compact, easy to read format.
Right.
So
Now, when I went to night school, Patrick, who was the professor, taught us about something called, oh my God, Splunk. Um, and now Graylog, I mean, how does Splunk and Graylog compare? How are they different?
Graylog, they're similar, but Graylog has I picked Graylog because they have a free model. So they have a community edition that's free for everyone. And then they have a paid version as well, that something that would compete with something like Splunk.
Yeah,
So this one has a dashboard. You could also set it to notify you. Because most people don't look at the logs unless there's something bad that happened. But here, if, for example, this count starts going up, you could have it alert you, email you know, or like a SMS notification on your mobile. So,
right. We're getting into the home stretch. We're nearing the end. I
yep.
mean, what other, if you were to less give people, hey, these 3 to 4 things you need to make sure you get right as it relates to related to cloud. You've talked a bunch of stuff. What would you say?
I basically layer your security, I think is the number one.
Yeah,
And always keep in mind that companies create their services for usability, not for security. You
right,
you don't want to just hit next, next, next because it's by default open. So
right. So
there's lots
layer
of
meaning if my perimeter firewall fails, my
right.
internal set of firewalls will help take over.
Yes.
That's one
Yeah.
example
And if
of the way to
that
do that.
fails, you have your host firewall to protect
Yeah,
you.
yeah, yeah,
So, right.
yeah,
So this is network monitoring system. Microsoft and Amazon has their own version. There's also free ones like Nagios and Zabbix. Datadog is getting popular. I think they have a 5 user version that's free.
yeah,
So, so what we have here, this is from a Zabbix dashboard. This is what Paul and I do. So we monitor health and we monitor security. So we know that it's running Windows Defender, antivirus, it's up to date, the hard drive is fully encrypted, um, so on and so forth. So again, this is a free network monitoring system. You can set it up in your office and you can keep track of all of your machines, um,
yeah.
security posture.
It's what
So,
we do internally. We need to do that. And then
right.
I personally employ FCI from an MSSP perspective. And they give me kind of a second check. But
Mhm.
we're, of course, doing that internally as well.
Right. So, and if you have like 100 machines, you could see it right in that dashboard, who is secure, who isn't. And away you go.
Yeah.
This one's a bonus. CAA record. This is when you log into a website, you have that little lock there. Well, that is protected by a certificate. This you turn on um your certificate of authority, like your DNS. I'm blanking out your DNS registrar. Um,
We could do a whole call just on that. And if we
yes,
think about spoofed or hacked emails, and
right,
I'll just let you take over, but
yeah.
I just want to
So
say this whole topic
right,
matters.
right. So this one here, we get Security Basecamp gets our certificate from Google. So this is like a 30-second thing that could protect you. You set this up in your DNS server. You add this, which is given to you by Google, and nobody can issue a certificate um, in your behalf because sometimes people say, well, I will pretend to be security base camp and I will acquire a certificate. That way, people will get that little lock when they access my hacking website. So, by doing this 30-second thing, you do it once, you never have to do it again unless you change your registrar down the road. You protect yourself from that type of attack. So, and that concludes my presentation. The bottom of this slide deck has resources, sample configs that you could employ in your network. So, Paul?
Yeah, yeah, thank you, Les. Yeah, I mean, you're exceptionally technical, and I think you delivered that in a pretty digestible fashion for a diversity of audiences. So I greatly, greatly appreciate that. Like I said earlier, even the smallest of RIAs that we do risk assessments for end up benefiting from some of the stuff that Les showed today. Um, Comments or questions. One I might have is, okay, we can lock up all these computers or devices in the clouds, but sometimes that makes business kind of difficult, right? I mean, what are some of the ways that configurations can actually kind of like developers, right? Sometimes like a guy like Patrick, right? The development environment might need to be less secure,
Right? Yeah.
right?
So typically you have a completely separate development environment, and
Amen.
access to that environment's limited to just those developers. They're not wide open to the public,
The
right?
first thing you showed, the zero trusting of
Of
only these
course.
computers,
Yeah.
devices, people can access
Right.
this environment. And then
Exactly.
maybe I become a little bit more open in that environment.
Sure. Well, not wide open, but yes. Um, you would put your resources where they all the resources could talk to each other, but access to that needs to be limited to your inside wall, right? So
Yeah.
you have your thick wall, maybe two walls, uh,
Yeah.
but the resources can talk to each other from that point on. But when you do put it in production, then you layer it, right?
A lot of it conceptually makes sense. And if any of the audience members that are here have questions, you're welcome to answer as well. But a lot of these concepts are no different than anything we've done to kind of protect important things over the last 1,000 years, right?
Exactly. So. And
Right.
if you look at the the fortresses that's still up, I mean they're ruins now because of weather, but they're still up
Yeah.
because of this layering, you know.
Yeah.
Um, so
Yeah. Thanks for joining us today. If you have any final questions, great. Next month, I think will be so I think the session we did today is tactically useful to literally everybody in America or the world. The next session will be a lot about, okay, so who's doing this hacking? What's the size and scale of it? How is it really impacting? Patrick will talk about some threat intelligence. Um, about who's really doing a lot of the hacking in our niche, and then what we should all do about it. I think it's going to be a super intriguing session to complement this one.
right. There's in the bottom of this, if you want to scare yourself, there's some free web test security. Well, Paul's
We'll
gonna
do
post a
scanning
PDF
too.
copy of this.
We'll scan and scare you if you want.
It's free. You just put in your IP address there. These are relatively safe. They're provided by large companies like SSL Lab is provided by Qualys. So yeah, and a
Yeah.
lot of the sites here. So yeah.
Yeah.
All
Nice
right.
job, Les. Anything Vincent or Patrick you'd want to
I
add
really
today?
appreciate what I heard. I learned every time. So thank you, Les. Really great job.
Yeah, you're welcome.
Yeah,
Yeah.
outstanding. Okay, great. And then there's a gal named Raphael in the background that like does all this magic to make these calls happen. And what we'd really love to do over time is, start to get hundreds of people on the calls, and then break out into study groups around a particular topic. It might literally be all about SIM, right? Or on a monthly call might be all about penetration testing. There's a whole bunch of people that I can get a pen test for $90, a year. How does that compare to what you're offering for, 10,500? How are they different? Well, they're drastically different, right? I mean, there's a much higher quality in terms of what you pay for $90 or something like that. It's not a pen test. But long story short, they get into those kinds of discussions. So thank you so much.
Thank you all.
Enjoy
All right.
your rest of the week.
Bye bye.
Bye bye.